Welcome back to Energize, the quest to learn about energy and electricity and heat and magnetism. Those are all the things that you'll learn about during this quest. Let's review our key point before we're getting started on mission 2 of level 2. Energy exists all around us in many forms. Energy can never be created or destroyed. It is transferred from form to form and can move from one object to another. Heat energy moves from one object to another through conduction, convection, or radiation. Electrical energy is constantly moving. An electric current flows through parallel and series circuits quickly and invisibly from one place to another using conductors and insulators to produce electricity. This mission is on current electricity. Our mission objective is to explain how current electricity moves electric charges. Our challenge questions: how is current electricity different than static electricity that we learned about last mission? Why does current electricity need circuits? And why are conductors and insulators important to current electricity? Let's first start by talking about how static and current electricity are different. Static electricity stays in one place. That's why it's called static. An electric charge in motion is called current electricity. This electric charge flows from one place to another quickly and invisibly. You can't see this charge moving, but it does move from place to place. The path that current flows is called a circuit. The flow of electric charges is not the same in all materials. So what that means is that some charges are going to flow better in some materials, and some charges are not going to flow as well in some materials. And we'll talk about what those materials are called later during this mission. But these, what they are called, we're going to talk more in depth later, are conductors, insulators, and resistors. Let's talk about circuits and the different types of circuits. Current electricity must have a place to flow. Static electricity can stay in one place and then move suddenly, but current electricity is really always on the move. It must have some place to go. For electric current to flow, electric charges must complete a loop, or in this sense, it's a circuit. There are 3 types of circuits. There's a simple circuit, a series circuit, and a parallel circuit. Here the diagram shows an example of each of those different kinds. You might think a simple and a series circuit look very similar, and in a way they are, but a simple circuit really only has a power source and a load, which is like a light bulb. A series circuit has at least 2 or one of 2 or more of those things. And a parallel circuit we'll talk about later this level. What's the difference between a closed and an open circuit? Remember, a current cannot flow if it has any breaks. A circuit is open if it has at least one break. That break can be because one of the wires was cut, or it can be because the switch is open instead of being closed. A circuit is closed if it doesn't have any breaks. That means it doesn't have any cuts in the wires, or that the switch is closed as well. So look at these pictures to help illustrate the difference between a closed and open circuit. Notice at the top picture a closed circuit and an open circuit. They show the difference because there is a gap, there's a cut in the wire, but in the bottom picture, the closed circuit is the one that has the light bulb turned on, and the open circuit is the one with the light turned off. There are no cuts in the wires, but remember, look at that switch. That switch is open, so that explains why that light bulb isn't turning on. Here, this is also a special type of circuit that's not producing any electricity because it's not forming a complete circuit. It's not going from one side of that light bulb to the other. It's only going to one side, so that's why that light bulb is not turning on. Let's talk about conductors. Conductors are materials that are made of easily charged atoms. Metals such as gold, silver, and copper are very good conductors. Most metals are very good conductors. Electric wiring that helps move electrons from one place to another is often made from copper for this reason, because copper helps that electric current move from one place to another because it is made of material of easily charged atoms. So conductors help move electricity from one place to another. Insulators, on the other hand, are materials through which an electric charge does not pass through easily. And these are also very important when it comes to circuits and currents, because they help us from getting shocked when we are touching a circuit or a circuit made from currents. Plastic, rubber, glass, and dry wood are examples of good insulators. We sometimes cover conductors with insulators to make sure that we don't get shocked by the electrical current passing through it. That's why you'll see rubber a lot of the time in the circuits that you might see in your house. When you've plugged something in, you're not seeing that wire. It's covered usually by that black or gray or some other colored rubber, because it helps us from getting shocked by that current. And as I said, they protect the wires and make sure that electricity stays in the current and we don't get hurt by it. Resistors are also materials that do not allow electricity charges to pass through it easily, but resistors help transform electrical energy to heat and light. And a light bulb, a filament, is a thin coiled wire that can get very hot without melting, so it helps transform the electricity that's coming from the current into some other type of energy that we can use. In this case, a light bulb. Most of the electricity passing through the filament is changed to heat. This heat causes the filament to glow, giving off light. And here you see a picture of a light bulb with a filament in it. Notice how the resistor is transforming it from electrical energy that we can't necessarily see into heat and light energy that we can feel and see. This is going to be the end of this mission, or at least this part of this mission. Please make sure that you have completed the other activities that are a part of it, as well as watching the other videos that are a part of it before you take the checkpoint.